Hey, welcome back to the channel. I hope you're all well. Thanks for joining me again. Good to see you. Today on my bench I have a Harman Kardon PM640 integrated amp. This amplifier belongs to my son, and we had a little discussion about this. He said he was having a problem with this amplifier, and I told him, well, if you have a problem with it, bring it here. You know, I'll sort it out for you. But he said he'd be listening to it and there would be a buzz or a hum. So, okay, maybe it's a ground fault or a ground loop or open ground, or maybe it's a power supply problem. We don't know yet. So I told him, bring it here and we'll have a look at it. I'll try it out. So he did. He brought it and I tried it out on my desk for about 2 weeks, and this amplifier sounds really good. It's got no annoying buzz or rattle or hums. I think it was probably more his input wiring. Maybe it was faulty in some way. It had a bad ground connection or something. But here it works fine. And I listened to it for, like I said, a couple weeks, and it was all good. It's a great sounding amplifier. It's got a nice tone to it, nice sound. But I did notice there is one little problem with it, and it's kind of an annoyance. And I think I can pinpoint exactly what it is, but here, I'll turn it on and I'll let you decide if you can figure out what it is. So here we go. Now, I don't know if you noticed, it took almost 10 seconds for that to come out of sleep or the muting. The also problem is when you hear it come out of muting, you kind of have a distortion signal and then it comes up in volume. That should be abrupt and not slow like that. So there's a problem in the circuit that does the power on muting. And here I'll show you on the schematic what I think is going on here. If you look at the power amplifier circuit, here's one channel and here's the other channel. Right at the input of the power amplifier channel, you have your long tail pair or your differential, whatever people like to call it, and that's in both channels. At the bottom of this, there's a transistor here, and this transistor, its purpose is to turn off or shut off, turn on or turn off the current that flows through this long tail pair. So when this transistor is turned off, there's no current, there's no signal going to get through to the outputs, right? And then when the amplifier turns on, there's a delay circuit that turns these two transistors on, this one and this one, and they both come on at the same time, and then they allow current to flow in the long tail pair, which allows the signal to flow through the amplifier. It's the power on muting. It's to prevent the big thump at the beginning. So if we follow this line, there's a capacitor here that kind of smooths out the signal on that line, keeps it, it's a DC level. If we go up here, where are we? Well, we gotta keep going, keep going, keep going. Oh, I gotta move the screen, hang on. Okay, that line comes from here, and this transistor is responsible for the power on muting. And if you look here, we have a little RC time constant thing. There's a 330K resistor, 47 microfarad capacitor, and as this capacitor charges up, that gives us our delay turning on this transistor. So I suspect this 47 microfarad transistor is bad, and it's probably high leakage, and it's causing this circuit to take a lot longer than it should to turn on. Either that or we have a bad resistor here, or maybe one of these other resistors are bad. But we're going to go in here, we're going to be really critical of what's going on here, because I think there's a problem with this circuit. And there might be other capacitors as well within the unit. So as far as I know, this has never been serviced. I've never looked inside yet. So we're going to pull the cover off, get our ESR meter out, and we're going to take a look at that one capacitor and make sure it's good, because a 10-second turn on delay is way too long. So let's get the lid off this thing and have a look inside. All right, cover's coming off. Let's have a look and see. A little bit of staining here. All right, so what do we see? We see a lot of cooked components here down in the power amplifier. You can see the board is nicely tanned around these areas where there's a lot of heat. So I'm going to suspect some of those caps are bad too in that area. I'm going to go through and check all of these. I should unplug this before I poke around again. There we go. Now the capacitor that's in question is back here within the power supply. I think it's C8, which is this one. There's a few other ones here. So we'll go through and we'll check these capacitors and check a few other ones here. Not much to these amps. The bottom comes off, which is good on these. So I'll go around and pull the bottom off, and then we can start checking some of these caps. So here's a look at the suspect cap. This is C8. This is a 47 microfarad, 16 volts, and is measuring out at 39 and dropping. Ever since I desoldered it, it's cooling off. It keeps going down, and the ESR just keeps going up. So, you know, as it cools, this cap is not within tolerance. If I heat it up with my fingers, you see it probably comes right back up again. It goes back, starts climbing. It's temperature dependent. It's failed. Doesn't seem as if it's bad enough to cause a problem in the circuit though. But I'm going to replace it, and then I'm going to test it with a new cap in there, see how long it takes to turn on. But I'm looking around here and I'm seeing a lot of other tired old caps that need to be dealt with. Here, I'll show you something right here. Okay, I don't know if you can see this, but right here there's a spot on this board, and then you can see this looks like a piece of trash or something, but it's actually corrosion. And if I scrape it off, that could be just circuit glue, or it could be a leaking capacitor, because there's a capacitor directly above this, and whatever stuff that was, it came over the edge of the board and it's causing corrosion here. Now, that might just be circuit glue that flowed over and onto the connections. I'm going to clean that up. I'm going to give this cap a good looking at. I think it might be leaking. Also, another thing I'm seeing is some of these transistors here where it's heat soaked. Starting to get cracked solder, as you can see the rings. So I'm going to touch all this up. I'm going to check another few more capacitors, make sure that they're good. But first, let's replace that C8, and we'll see if it brings back the correct timing for that circuit. All right, so I got a new cap soldered in for C8, and I wired it back in. So we're going to do another test here and see how long it comes to life here. So let's try this out. I still don't think it's doing its job. It took, I don't know how long that took. I don't know if you guys were paying attention. It took about 6 seconds in my head. It seemed to be getting better, but I don't think we're quite there yet. So I might have to check a few of those other components. And you notice how it kind of just goes, it has a limpy fade in. It should be instant. It should cut in. Let's try that again. Yeah, it's a little better, but still not there. So let's keep poking at it. Okay, I'm looking at this with a lens here. Some of these transistors definitely are cracked. I don't know if you can probably see them moving. If I fiddle with the top side, you might be able to see them moving. Probably not. Where's my finger? Okay, right there. There's a transistor right here that's loose. Something's loose here. So I'm going to solder all these transistors back up. It's not good. And looking at the way they cut these leads off is just horrible. I'm just trimming them a little better. But we got some long leads here, and I don't know if that's a short. But I'm just going to clean up these solder joints because they're definitely a problem. It's funny, I never heard anything going on with this amplifier when I was listening to it. Usually you hear crackling and pops or channel cutting out, or even it just grenades itself because it's got a wrong voltage somewhere. But let's just touch these up again, and then we're going to be back in business. This one here. Really tiny pads on these. That's probably part of the reason why they crack in the first place, is because you got a small pad, and then when they do the flow soldering, maybe not enough solder sticks to the board, and it's not an ideal joint. And then after 40 years of thermal cycling, it cracks because it's a weak spot. So, but anyways, what do I know? Let's just touch these up. And touch up this one too. This one was corroded. I think that is fine. It was just corrosion. Okay, I'll do the other channel at the same time here, and then I'm looking at these caps. I'm testing and pulling a few out and testing them, and they're all pretty old and tired. So I think I might just do a full recap on this thing because it's showing its age. So what I've done is I replaced the other two capacitors that were in this little circuit here. One of them is a 10 microfarad at 16 volts. The other is 100 microfarad at 25. And they both check weak with my tester, like the ESR is high and the capacitance is starting to fade away. So I replaced both of these as well. That did nothing for the time constant though, because the time constant, I turned it on and I was still getting 8 seconds before it would come alive. So what I did is that capacitor resistor network there, that RC network that is responsible for the timing, there's a 47 microfarad and a 330k resistor. I took out the 330k resistor and scabbed in a 220k. So now you can see the turn on delay is a lot less. So let's try this right now. It's about 4 seconds. But you can also hear there's a little bit of a, you can still hear the amp settling as it comes alive. You can hear there's a 60 hertz hum in there. That tells me that there's still transistors that are settling and turning on. I want to leave this 220 in here because it's the right time constant. It's about 4 seconds to turn on. I think 8 seconds is too long. But what I want to do is I want to recap this power amplifier because I think there's bad caps in here, and I think it's causing a problem with maybe when it's turning on, maybe it takes a little longer to settle because of those caps. So I'm going to go through and do that. There isn't very many caps in this thing. If I look on this, board, this is all the power amplifier here. There's 1, 2, 3, 4, 5, 6 capacitors. And there's a few here in the preamp stages, not many. And yeah, it doesn't take much to recap this thing. So I'm just going to put new capacitors in there, and we're going to see how it behaves. All right, so I got some new caps in here. I don't know, maybe replace maybe 10 on this board, 13 altogether on this whole main board. I didn't touch anything back here, but I just want to see if it behaves a little differently compared to what we were hearing before. So I still have that 220 kilo ohm resistor in place instead of the 330, and we're going to turn it on here and see what kind of a delay we have and how it boots up. And I'm still getting a 60 cycle hum. Okay, I think the next step here is to set up the bias, and then I think I'm going to finish it up because I don't think there's anything more I can do. Okay, we're set up to do a bias adjustment. I have my voltmeter connected to this channel here. Just a thing to note, my watt meter right now is showing 34 watts consumed, and the specification in the service manual for bias is 33 millivolts measured across both emitter resistors. So here I got it set up for both emitter resistors. I'm measuring 63 and it should be 33, so we're way high. So I'm going to tweak this down. Where's my pot? It's hidden here. Okay, let's start cranking this. Okay, I jumped there. I was going down and then it jumped. It's quite a bit of adjustment I had to make. 33.6, that's good enough for now. I'll let it cook and settle. Let's do the other channel. And this one's high as well. It's 56. Okay, let's turn this one down. Oh, it's opposite. I have to turn it the other way. This pot might be a little dirty. Okay. I'll let this cook for about 20 minutes and then I'll come back and check her. Alright, so I'm back. It's been a while. Let this thing cook for a while. It's consuming from the outlet 2930 watts now, and this one's at 33.6. I'm going to leave that one alone. Let's check the other channel quickly, make sure it hasn't drifted up or down. And we're at 35. I'll just turn this down a little bit, just so they're both balanced. All right, so I'll wrap this up. I'm not going to do a power test, but I am going to, I think I'm going to leave that 220 ohm or 220k ohm resistor in place, just because how it's performing. Let's see here. Let's shut it off and see how long it takes to come back on again. Yeah, I don't know. Is that normal for any of you guys out there that have a PM640? Is it normal for it to take 10 seconds to start up? I would think it'd be more like 3.5, 4 seconds. But maybe that is normal, 10 seconds. I don't know. Let me know in the comments what you guys think if you have one of these. But I'm going to leave this alone. I'm going to put it back together. Well, there you have it. It's back together. I'm going to put it up back in service, and I'm going to put this on my desk and give it a good listen to. I'm more curious to see if the capacitors I just put in there made any difference in the sound quality. And like I said, I made that change to that resistor. I moved it from a 330k to a 220k to cut down that time constant. And what did I put in here? I put like 15 caps. Not a very big deal. It's a little, some of these were getting weak. A lot of these are still serviceable, but they're all going in the garbage now. So I'm going to try this again, listen to it, and see how it is, and I'm going to return it back to my son. All right, thanks for watching. Stay tuned. Got lots more stuff coming up. Hopefully you'll find it interesting. I know I do. Okay, take care, and thanks for watching.